What's up, math fans? Today I want to talk about how to use reference angles, and I really want to explain it so that it makes sense. Because if it makes sense now, you will get a career that makes dollars. Alright? So, here's some background information that you've already seen in my videos. Here's a table with values that you've memorized. These are the trig functions of really basic angles. They're not the only angles that exist. Understand that 1 degree exists, 5 degrees exist, 76 degrees exist. All angles exist, but these are very special angles because they're found in special triangles. So these are the more common ones, and it helps to memorize their function values. So again, there's that table that you memorized. Also, there's a bigger table that I will introduce that includes the quadrantal angles. 0 and 90 are also very important angles. But for this video, these are going to be my popular reference angles, something to refer to. When you hear SOHCAHTOA, again, that's not a word, it's just an acronym that helps you remember 3 formulas. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Those are my sine, cosine, and tangent formulas. Sine, cosine, and tangent, well, that's trigonometry, which is basically a study of right triangles. So it helps if you have an angle, and then you can manipulate the sides to find your ratios, your fractions. However, what if you're dealing with angles that can't be found in a right triangle? Because if I'm dealing with a right triangle, then my angles I'm usually looking at is either A or B, and those are acute angles. So what happens when you have angles that are obtuse or even bigger? Then you can't quite find the sine, cosine, and tangent of them, but you can refer to a reference angle that will help you. So here's what I mean. First of all, understand when you're looking at an angle, understand what it looks like. So if you can draw it, draw it. So what does 60 degree look like? Well, on a graph, in standard position, your initial side is always here facing 0 degrees, and my terminal side is 60 degrees, is approximately right here, 60 degrees. That's a quadrant 1 angle. Notice I didn't use a scale. I could have easily put a protractor here and measured it exactly, but you just want to get an estimate of what it looks like. So 60 degrees makes sense to me. It's fine. It's an acute angle. It's in quadrant 1, and that's all I need to know. But here's some other information. Let's say I wanted the sine of 60 degrees. So rather than draw a triangle and figure out values and do opposite over hypotenuse, we already worked through that. You've already seen that video. So now if I ask you for the sine of 60, it's radical 3 over 2. Boom, I'm done. I already knew that. Radical 3 over 2. If I ask you for the cosine, you can give me an answer, half. If I ask you for the tangent, you can give me an answer, radical 3. And again, that all comes from a special right triangle that we dealt with already. So, why is it so important to know this? Because when I get to bigger angles, I'm going to need to refer back to this. A reference angle is defined as an acute angle formed by the terminal side and the x-axis. So as soon as I draw my given angle, I will highlight the terminal side, which is this. I'll connect it to the origin, which it naturally is there anyway, the vertex. And then I'll highlight the x-axis. And this is therefore my reference angle. So a reference angle of an acute angle is already its own itself. I don't need it because it's already acute. A reference angle is an acute angle. So if I'm drawing an acute angle, it's its own reference angle. So here, if it's a quadrant 1 angle, if it's acute, the reference angle is itself, theta. So if it's 60, the reference angle is 60 is itself. But what if it's a quadrant 2 angle? So here, let's draw 150 degrees and see what happens. This is just a warm-up. If I quickly ask for the sine of 30, by now you got to either know it or know to refer to the table, or even the calculator could tell you, but the calculator again tells you a rounded answer. I'm asking for the exact value. Rationalize the exact value. So sine 30, boom, right there on the table, 1/2. That's just common knowledge that you should have. Let's move on. 150, what does it look like? My initial side again starts here on the x-axis, and now if this is 0 and this is 90 and that's 180, 150 is a little short of 180. So here, this would be about 150 degrees. Again, if you had a compass, you could check that. A protractor, you could check that. here's my thing. 150 is not found in a right triangle. So I need a reference angle to find the sine, the cosine, and the tangent. I'm only asking for sine in this case. My reference angle is defined as the terminal side and the x-axis. It's the angle formed by the terminal side and the x-axis. So it's this space right here. So remember when I was describing how to draw 150, I said it was just a little bit short of 180. This would be 180 straight line. So when I say just a little bit short, there's no guessing here. There's an exact value. How short is it? Well, if this is 150 to get to 180, that's 180 minus 150. This little space here is 30 degrees. That's my reference angle. Reference angle is 30 degrees. So if I'm asking for sine 150, you don't know, but you do know that it's the same as if I was asking you for the sine of 30 degrees. And oh yeah, we do know what that is. That's 1/2. Okay, so again, my answer is 1/2. Number 2 and number 3, same question. And if my angle lands in quadrant 2, how do I find the difference between the terminal side and 180? Well, just subtract 180 minus the given angle. But if that terminal side passes 180, now it's bigger than 180, well then it's a similar formula. This time I just do the given angle minus 180. For example, give me, let's see. It doesn't matter what order you do this in, but let's see. Can I see a 300-degree angle? Draw one. If you draw one, you're already planning ahead because you know this is 0, here's 90, here's 180, here's 270, 300 is a little bit past 270, and not quite 360. It's not quite a full turn. So it's somewhere here, not exactly sure where, but I know that that spin is 300. And it's a little bit short of 360. How short? See, people get confused and they say, oh, let me just find this space here because they're worried about the 270. And they find the difference between 300 and 270, which is not correct. The reference angle is again formed by the terminal side and the x-axis. So it's this space here, that orange space there. And that comes from, since it's a 4th degree angle, I'm sorry, a 4th quadrant angle, that's 360 minus theta. Notice I never use 270. I never use 270 to find the reference angle. So 360 minus 300 is what? 60 degrees. So I'm really asking for, the reference angle is 60 degrees. So I'm really not asking for the cosine of 300. I'm asking for the cosine of 60. And, oh, just run to the table. Cosine 60, 1/2. So my answer is 1/2. Coincidence that they're all the same? Kind of, but I mean, you're only going to get so many numbers because I'm specifically going to my special angles. If they ask for other angles, then you might have to run to the calculator. So they wouldn't say exact value. They would say round to the nearest 4th decimal place, right? Not the tenths, not the hundredths, maybe the thousandths or the 10,000ths. All right, last one, 10 to 10. Where is 210? Let's see. Again, 0 is here, 90, 180, 270, that's too far. So 210 is somewhere over here. 210 is the spin around right there, right? Because my angle's open counterclockwise. So where is that? I don't know. Here's the terminal side, here's the x-axis. This space right there is my reference angle. So the reference angle of 210 degrees would be 210 minus 180, 30 degrees. So I'm not asking for tangent of 210. I'm asking for tangent of 30. All right, because the reference angle behaves just as the given angle. They have the same behavior. There's a little twist which you see in my other video that explains whether the answer is going to be positive or negative. I specifically picked positive answers. You'll see when they occur negative. So what's the tangent of 30? I wish I knew. Oh wait, I do know. Tan 30, radical 3 over 3. And I'm done. All right? Hope this helped. Thanks for watching. See ya.